Hello all and welcome back. So in this video, let us continue our discussion on trees and now let's see if we can improve our take input function. So let's get started. Now in the last video, we saw that though we were able to take the input, the same was not a lot intuitive and something which would require any normal person to have the knowledge of recursion, right? So now what we want to do is we want to make sure that somehow if we can take the input in a better way. So for that, let us first try to make a tree. Let me just quickly draw one tree. So yeah, let us create some nodes. Great. So let's say we have some 1, 2, 3, yeah, 6 nodes we have. Okay, let us join them with each other. Great. So we have these 6 nodes, everyone. Now in these nodes, we saw in the last video that how giving the input via recursion was not very easy. Plus, we were actually taking the input for 1, then 2, then 3, then 5, then 6. Then I used to come back and then finally go to 3. Okay. So what I have to do is I have to first make sure that I complete one full subtree. Then I go on to the next, then to the next. Instead of this, what effectively I would like is that if I can give this input level wise, right? So at each and every level, now we talked about how this is level 0, 1, 2, something like this, right? So at each and every level, if we are able to give our input, that would be a lot better because let's say I enter 1. Now I know that for 1, I have 2, 3, and 4 as its children, right? So something which I will have a better knowledge of. Once I have completed this level, then I can move on to 5. Okay. The benefit will be that I should not have a overall knowledge of recursion, the way we are going to implement this. Second is that you will not be going a lot deep into a particular subtree. Okay, because we used to return here, and let's say if I have some more nodes here tomorrow, then it's going to be a lot more difficult. Okay, so that's the basic idea, that the node which comes in first, we are going to work first on that. So for example, we will have 1 first, we will work on this. Keep on working on this until it gets over. Then next we will work on 2, then 3, then 4, right? From 2 we will not go on 5 because then 3 and 4 have to wait for a long time. Okay, so again I will repeat what the mindset is. The idea is that we are going to take the input. So taking input level wise. Okay, so we will have to take the input level wise. That's the first thing. Second is that once we have to do the same, we will process our nodes. The first to come will be the first to get processed, right? First to get processed. Now I think if you are able to catch some wording here, we are kind of saying that the node which comes first will be the one which we will act upon first, right? That is what we will be doing. So first we will talk about 1, then 2, 3, and 4, then 5, then 6, right? So in our tree as well, when we draw, this is the first, then second, then third, then fourth, fifth, and sixth, right? We have uh, given them the value which is in the order as well. For this, I think now all of you must have actually guessed, we can actually use a queue. So we can very nicely use a queue. So the basic idea again is that whatever node you are saying that add into a tree, I will be pushing them into a queue. Make sure that I work on that particular node. And once the work is done, let's say you ask me for the first node. So I'm going to push 1. Then for 1, I will pop out 1. Okay, I will dequeue 1 and then ask you that, hey, how many children are there for 1? you will say that 2, 3, and 4. Okay. Once you have given me this 2, 3, and 4, next I will actually close my work on 1 and then ask for 2. 2, you will say 5. Okay. Then I will ask for 3. Then I will ask for 4. So if you will see, I'm working in this particular manner, right? I will ask for 2. Once 2 is done, I will remove it. Then 3, then 4. Then I will come to 5. So finally, I'm going to come to 5 and ask for 6. Then you will enter 6. So this is the way we are going to process our overall nodes. So let us now try to code this, everyone. It's going to become a lot more clear then. So I've created a new file, everyone, in this take input better. Now, first let us import the basics from commons, import the tree node and print tree detailed, right? For Q, I will be using from collections, import DQ, right? Deck or DQ, whatever you want to say it. Now, reason I'm using this, of course, you can use a list as well. We can just pop from 0, right? And append into it as well. Is that normally you will see that in Python, we are using deck only everywhere, right? So I want all of you to be comfortable in this while using it in future as well. And it supports all the operations, right? So just like a list supports all the operations, I just have to make sure that I am able to use it pretty nicely and just the operations which I want, no extra operation. In case you want to use, actually you can use the one which we created in the module before to overall, let's say use our queue in this particular code. Okay, great. So something on deck, although we have already seen this, let's say if I'm making a queue, it can be made like this. So I can provide an iterable here, right? And if I now do queue dot pop left, then is when I will get this one because it works in this way. So this is left, then left, second left, third left. Okay. Pop will give me 3, while pop left will give me 1. So let me run this. We have to print it, right? Print. We have already seen this in the queues question, but should be fine. Okay, let me just explain it to you again. This is 1. If I would have done pop here, I would have gotten 3. Now I will be pushing it or appending my item. So I have to make sure that I get the one which I appended first. For example, in this, 1 is the one which came in first. So to serve it first, I will be using pop left. Okay. Let me run it again. Yeah, it's 1 now. So great, everyone. I hope this is clear. A good quick refresher. Now let us try to write our function. Take input level wise. Okay, so that is what I'm calling my overall function. Take input level wise. Very first thing, I'm going to ask for the data of my node. So enter the data of my root. This time we are not using recursion. We are instead using our queue. So it is fine if we are saying root data here. Okay, great. So once we have the root data, we can create the root. It can be using tree node and data. So till now we have created the root. Now once the root has been created, once this one has been created, this is something which I should push into my queue. Okay. So to do the same, what I can do, I can create a new queue with this. And let's say I'm just adding root here. Okay, everyone. So I hope it is clear. One thing to note here, you will be adding root, not root.data. The reason is that in future, I want to access the children. So one should not be added here. Okay. We will be adding the whole root, the reference to my root variable, root node basically. Because in future, I will be using this particular root to add children to this particular tree. Okay. So I have added one here, but it is having this particular list as well, the list of children. Great. Once this is done, then I think we can write a code. So while my length of queue is not equal 0, okay, the same thing can be written as while queue is not none. So while queue, that also works. Okay. While length of queue is not equal to 0, what I can do, current node, it's going to be queue dot pop left. Okay, so I'm getting the active current node which I have. Now I should ask that, hey, how many children do you want? So int input, enter the number of children for, and let me do it in a different way, not F formatting, str current node. Okay, so in this way, we can also do it in this particular way, everyone. Let me zoom out. Yeah. So I'm just asking that, hey, tell me the number of children for this particular current node. Okay. Once I have the children, then again, I will be running the loop. So for I in range of num children, I have to write my loop. First, again, I should ask for the child. That what exactly is the child. So child data, let us use this. And this time I can actually make it a little bit more enhanced. Enter the data for, I can actually use I here as well. So let me use F here. Okay. F formatting and I plus 1. So that we will be getting a lot detailed overall input. Okay. So to get rid of the problem we had in the last overall our implementation of taking input, here I'm saying, hey, enter the data for I plus 1 children or child of current node. Okay. So I'm just specifically asking, and it is I plus 1 because this I starts from 0. So I will be asking enter the data for first child of current node, that is 1. Second child. So in this way, we will be having a lot better overall uh, prompts which we can use. Okay. So once this is done, then what I have to do, everyone, once you add or give me the data that, hey, please create 2, I have to make sure that I create a node. So child node is going to be tree node with this data. Okay. So now I have created the node with value 2. If I have created it, then I should add it here as well. So child, no, current node dot children. Okay. Dot append. That is why I was saying that we need the node overall. Okay. We need this root, not root dot data. Let me append this overall. I will have to also append this to my queue because I have to work on this in future. So child node. And yes, I think this should work. Let us just return root. So first let us run, let us run this and then let's see how exactly we can debug the same. See, great. So let us run this file. It is take input better. Okay. So okay, my bad. We have not called this particular function. So root take input level wise, and then I can print tree detailed root. Cool, everyone. I think this should now run. So let me clear everything. Okay. So I will just repeat what all we have done. A little long video, but yes, this is something which you have to understand. The same understanding is going to be a lot helpful when we understand graphs and other data structures moving forward. So as we discussed, to take input a little bit better way, and you will now see how good it is overall. Okay. We have taken the root and we have maintained a queue using the dequeue basically in connections. Now I am making sure that I work on each and every node as and when you give me. So I'm going to take the input level wise. You give me the root as 1. I will ask you all the children of 1. Then I will work on 2. Ask you all the children of 2. Then 3, then 4. So it will all be in a level wise situation. Okay. Great. So yeah, let us work on this. Let me try to run it. Great. So it is saying a specific perfect question. Enter the root data. I add 1. Okay, I think we made a mistake here. We should be current node dot data. Okay. So let us get out for the timing. So we made a mistake here, everyone. What we did was we should ask for current node dot data, right? Current node again is having the address of the node, the reference of the node. Okay. Great. So enter the root data 1. Enter the number of children for 1, 3. Enter data for one child of 1. Okay. So we can maybe make it a little bit better. Child 1 of node this. Okay, so in this way it will perform a lot better. Let me just clear this. Just that we are trying to improve the prompt. Enter the data for child of node current data node. Okay, Cool. Let us run this again. I think it will be all fine this time. Enter the root data 1. Enter the number of children for 1, 3. Enter the data for child 1 of node 1. See how specific the questions are, right? So it is asking me very specific question. Now I am on 1. I can actually even go back and come and I won't have to see that, okay, where I was. In the last overall execution, we have to actually see that how the recursion or till where recursion has reached. It is asking me very specific question. The first child of node 1, it is 2. Enter data for child 2 of node 1, it is 3. Enter data for child 3 of node 1, it is 4. Great. Enter number of children for 2. See how specific the question is. 1. Enter data for child 1 of node 2, 5. Enter number of children for 3. Now see, it is not going in depth of this particular tree. It is asking me here that, hey, please first just complete this level so that you don't have to return here. We will talk about 5 afterwards. Now, once this is done, enter the number of children for 3, it is 0. For 4, it is 0. Then it is asking me for 5. So 5, I know that 1 children is there. Enter the data for child 1 of 5. It is 6. And enter the number of children for 6, 0. And see how nicely are we able to give the input now. Okay, everyone. So let us just try to dry run this once. What exactly would have happened here? Let me close this and let me try to run this all in a Python tutor. Okay. Again, will not be a lot better visualization because with linked list we were having some finite nodes and they were getting connected one after another. Here also nodes are finite, but they will be all over the place. But let us still try to visualize and see how we will see it. Okay. So first thing, again, we have the take input and we are asking for the root. Okay. Great. So it is asking me for the root data. It is 1. Great. So we are creating a root. Pay attention, everyone. Okay. Root tree node. My bad. We have missed the tree node overall. So let us copy this tree node. This time we will give a smaller tree. So should be fine just to see the execution. Okay. So tree node, take input level wise. And okay. So it is going here. The root data is 1. We know that. Okay. So root data it has taken 1. Then we are making the tree node with 1. And we have created this as my root. Great. Next I'm creating a queue. So we can see this queue. Okay. We are not able to see the item inside queue because it is not optimized to show, but should be fine. DQ as of now is this. Okay. What we have done, we have popped from our queue and the current node is this only. Okay. So it is asking me for number of children. Let us say this time it is 3 only. Let me draw the tree as well. So we are able to imagine for which we are working, right? Tree is like this. 1, 2, 3, 4, 5, 6. So as of now, what we have done, we have created this one. We added this one here. It got popped out. And now we are asking that, hey, please first work on this one. Tell me the number of children. I gave that it has 3 children. So it's now going to work and run a loop. So let us see that loop, everyone. It is asking me enter the data for child 1 of node 1. It is 2. Let us submit it. And we see how it's going to get created. See, pay attention, everyone. In it, it's going to create a node. So this node gets created in the memory. Once this node is created, okay, in the child node, I'm going to make sure that I join this. See, I have appended it here as well. And next, I'm going to just add it here. So this tree node object, okay, it is showing us as a tree node object. That should be fine. If you would have added the data, we would have seen that. But this will just help us to imagine. So first, overall children, the 2 has been added here. Now let us move forward. Again, it's asking me for child 2, which is 3. So let's submit it. This time child node will be created with value 3. So I will see the child node as 3 here. Pay attention, everyone. This is child node as 3. Its children are empty list. Let us move forward. And we have added, see, the children with 1. We have 2 here. We have 3 here. Let us move forward. This has also been appended. Because it is a tree node object, it is showing it like this. Should be fine. Now let us move forward and say enter the data for child 3. It is 4. Now again, same thing is going to happen, creating a node. Once the node has been created, appending it to the one child, right? Now you will see one thing, that one has actually left the queue. And the other items in queue are 2, 3, and 4. Okay, so if we are maintain, we let us maintain a queue here rather. So the items in my queue are something like this. One has already left, 2, 3, and 4. Next, I'm going to pick up 2. Once I pick up 2, then what happens? It's going to again ask me for that. Okay. So see, while length of queue is not equal to 0, I don't feel it is 0. It is having 3 length as of now. When I go in current node, it pops. So this particular 2 is now popped. This particular 2 is popped. So what we can do? We can just remove it. Okay. It is asking me for number of children for 2. Let me just add a single children. Okay, so let us make this till 5 only. Okay, else it's going to get a lot messy. So pay attention. Now we have added it, one children. It's going to ask me that, hey, can you tell me the data for child 1 of node 2? For this node 2, what is the data? It's 5. Great. Now the second I add 5, it will get appended to 2. So pay attention everyone here. A node with 5 is going to get created. And it will get appended here. So again, as I said, the tree might not be very easy to visualize. This is one. Okay. This is our 2. Just I want to make sure that you have this understanding. So children, this is 1. These are its children, 2, 3, 4. And then 5 is there, which is connected to my 2. Okay. We can maybe remove this as well. Great. So as of now, if you will see, we are able to create some tree, right? We know that we are able to see this, that exactly how it will be happening. And my queue right now is having 3 and 4. So they are waiting for its turn. Now 5 will also get appended here. See, we have 5 also appended here. Now once 5 is appended, let us move forward. This time, number of children for 3 are getting asked. So let me add 0. Cool. So 3 is also popped out, everyone. 3 we have seen is popped out. And we saw that 5 is getting added here, right? So sorry for this little mess up, but I hope we are able to understand a little bit. See, 4 and 5 are here. Now it's going to ask for 4. Enter the number of children for 4. 0. Okay, great. So maybe we can draw it for the full tree which we have drawn. Let us draw it quickly. Enter number of children for 5. So 4 has also now been popped out of my queue. If I say 1 now, okay, 5 has been popped out. So my queue idly is empty. See, the queue is empty now. Because I have said that, hey, I want one children of 5. We are currently here. This whole level is done. Now we are working on this level. Enter the child 1, which is going to be 6. It will get appended to my 5 and as well as in queue. So see, creating the 6th node, appending it to my current node children and appending to queue as well. See, the queue has this item now. So again, it is not empty. So it will make sure that it works. So everyone, I'm making sure that you are able to visualize this whole stuff, right? Please uh, try to visualize everything. You can see in front of you that how our tree is getting created, right? So if I just break some connections, let's say this, you will see that some tree in the exact form is getting created, right? We have this particular one. One has 3 children, 2, 3, and 4. 2 has this one children, which is 5. And now I'm going to add 5 as the children of 6. Okay, 6 has an empty list. So now if I move forward, again it's going to come out. I'm going to get length of queue is not 0. I'm going to pop left the 6th node. It is asking me for number of children for 6. It is 0. Let me submit it. Okay, so and now finally pay attention. Because number of children are 0, this loop is not going to run. This loop will not run because it is range 0. And finally my queue is empty. So we will come out of my overall loop and we are outside returning the root. Once I click next, you will see just we have this root. So much like linked list, let me clear all these things. We have our root where the whole tree is there. With this root 1, we have its 3 children 0, 1, 2, 2, 3, and 4. 2 has one children which is 5. 5 has one children which is 6. So Yeah, I'm pretty sure that this overall level of visualization will be a lot helpful in understanding what exactly is happening behind the scenes, right? So my whole approach is to make sure that you visualize. Once you are able to visualize that exactly in the backend, this is what is happening, you will be at a very good level to write codes going forward. Okay. So cool, everyone. I hope you were all clear. So we have seen how exactly it will work here as well. Then we saw the code, and then again we saw exactly how it is working in the overall backend. Okay, so cool. Just try to write it once more, I will say. Overall, I feel that it is not very difficult, just that this might be the first time you are actually writing or using something like this where multiple data structures are involved. So that's why I spent the time on this as well, because I want that you should not be scared of this. You should just understand that we are using Q in a way to make sure that we are able to work on this. Okay. So yeah, cool, everyone. Let's meet in the next video, and we will try to now expand on our understanding by doing some question on the trees. Thank you.